So this chapter is basically talking about equations and how to solve equations. So that's what tonight's going to be about. We're going to start out section 1.1 with one-step equations. Okay, and some of these I understand you'll be able to just look at the problem and know the answer. What's more important to me right now is that you understand, like algebraically, how to get the answer, because when we go to two-step equations and then more steps, you're going to want to know how to algebraically get the answer. Does that make sense? So that's what we're going to be working on tonight, and we are going to go ahead and get started with that right now. So again, I know some of them you'll just be able to look at and you'll say, oh, that answer's 7. Oh, who cares? Whatever. But bear with me, because I will be showing some work here, and I want my red marker and my blue marker. What?
I said, don't be yelling the answer out.
Yelling the answer out right away? Okay. So the first thing we want to think about is this question: is -5 a solution to the equation given right there? Now, a solution, remember, or you may not remember, a solution is a number that if you put it into the equation, it's going to make it a true statement. Okay, that's the goal. So if they ask you, is this -5 a solution? You're going to take the -5, and what they're saying is x equals -5 a solution? That's the question. So you're going to take that -5, and in place of the x, you're going to put in this -5. Just like substitution, like we did last week, right? So we're going to put in the -5. And you can use a calculator or not, but I don't have a calculator, so you're going to help me out. What is 4 times -5? Multiplication goes first, right? And what is 4 times -5? -20. And you can use a calculator for that, but -20 plus 16. And again, this is really a question mark. Is this going to be true or not?
Yes.
-20 plus 16, is that equal to -4? Yes. So putting in a -5 makes a true statement. So the answer to this question is yes, x equals -5 is a solution. Does that make sense? And in this case, that's the only solution. If you put in any other number, it would be not a true statement. It would be a false statement.
When we're writing an answer, if we have a question like this, do we have to write everything, or can we just put?
You can just put yes.
Yes.
Because again, the computer's going to look at it and they'll probably have a click box, yes or no. So it's going to be pretty easy there, I think. All right, let's take a look at another one. Oh, I just gave away the answer. Okay, well, we'll pretend I didn't give away the answer, because what's going to happen this time?
3.
We're going to put in a 3, right? So if we put in 3 here, this is 4 times 3 is 12 plus 16. Is that a true statement?
No.
No. 12 plus 16 is not -4. 12 plus 16 is 28. So does 28 equal -4? No. So we would say no. The answer to the question is no, it's not a solution. Okay. Now the reason we go over that is because in every one of these problems that we do, if you want to know if you have the right answer, you can take the answer you got, put it back into the equation, and see if you get a true statement. You can check your answer on every one of these. Okay, and I'll show you how to do that. But do those two first examples make sense? Okay, now we've got, and I've just listed them on your paper, but we've got a bunch of equations, different types of examples to go through. Yeah, they are equations, but different examples. And I want to talk about something first, and I'm sorry this isn't on your notes, but we want to talk about the idea of, the fancy word for it is called inverse operations. Now what that means is, or what that's talking about is, how do we cancel things out in math? Okay, we cancel things out in math by doing the opposite. So if you're trying to cancel out addition, we're going to subtract to cancel that out, right? If we want to cancel out subtraction, we're going to add. And then if they're multiplying and we want to cancel out multiplication, we're going to divide. Okay, and if you see division and we want to cancel that out, we're going to multiply. So addition and subtraction cancel each other out. and then multiplication and division are going to cancel each other out. So we're going to use that idea throughout the night tonight. Okay, so if you don't remember that now, you will remember it by the end of tonight. I can almost guarantee you. Almost. I'm not going to really promise. Okay, so our first equation here, and again, you might be able to look at it and just say the answer, but our goal is to get this, oops, that's the wrong color, to get this variable, this x in this case, and I think I used x for all of the variables, but anyway, whatever the letter is, this variable, all by itself. And when I say all by itself, this is also an important sign, the equal sign. The equal sign divides the equation into two sides, the left side and the right side. We want the variable to be all by itself on one side, either on the left or the right, it really doesn't matter. So that means our goal is to cancel out or get rid of this 7. Okay, does that make sense? Because the 7 is by the x. So whatever's by the x, we want to get rid of whatever's by the x. Okay, because our goal is to get x equals, and that's it, and then whatever number. So, thinking about what we just talked about, what's the inverse operation for addition?
Subtraction.
Subtraction. So the idea is if the equation is adding 7, to cancel that out, we're going to subtract 7. Okay? Now here's the thing. Think about a balance, a scale, a balance, right? Have you seen a balance or a teeter-totter? You know what a teeter-totter is? Okay, let's say the teeter-totter is balanced. If I take off some weight on this side, what's going to happen? It's going to tip, right? I want to keep it balanced. I want to keep it equal. So if I take off some weight on this side, I've got to take off some weight on this side also, right? So if we subtract 7 on the left-hand side of the equation, we've got to subtract 7 on the other side of the equation also. That way it stays balanced. Does that make sense? Okay. If I'm being too simple for you guys, if you guys already know this, just tell me and I'll move faster. But okay, it's good. Okay. So this will cancel out. Does that make sense? 7 minus 7 is what?
0.
0. So it's like it cancels out. Does that make sense?
Mm-hmm.
So now we have x equals, whoops, I was going to switch colors. X equals, and -5 minus 7. And if you need a calculator for that, you can use it, but I'll assume that you can use your calculators to do that, and that is -12. Okay? Does that make sense? And so that's how you solve that equation. One step, right? One step equation, one step, and we're done. So this is our answer. This is our solution. Now, if we're not sure, oh, maybe I made a mistake, we can go back and check our solution, just like we did in examples 42 and 43. So what we do is we go over here and we say, okay, replace the x with the answer that we think is the solution, and you just plug it in. And again, you can use your calculator. -12 plus 7 is -5 equals -5. Good, we got the right answer. It did what it was supposed to do. Okay. So does that make sense for the first one? And really, all of these problems on this paper are going to be just like this. You just have to do one step to cancel out what's there. All right. Any questions before we go on? Because if you have a question, I want to make sure I answer it before we go on. All right, because then I start erasing things and whatever. All right. My erasing isn't going very well today. All right. Next one, I've got 3 equations here, but again, they're one step each, so we're going to go through these. Somebody help me out. Now, they switched the order on this, right? But here is the equal sign. Here's the left side and the right side. What are we trying to get rid of to get the x by itself?
4.
This 4. Okay? How do I get rid of this 4? Subtract 4. That makes sense? Because 4 minus 4 will equal what?
0.
It equals 0. It cancels out. Right? So now we have x on the left and 4 on the right. And x equals 4 is going to be our answer. Again, in this lesson, one step and we're done. Okay. Unfortunately, not all equations are like this, but in this lesson, they're all like this.
How do we know?
How do you know what?
Well, like,
If it's more than one step, it's going to look longer. Well, we're going to go through.
because I guess what you
Oh,
To show the work, right?
yeah, you show the work. So once you get your
That's
x
right,
by
yeah,
itself,
because you can-
then you're done.
Right.
I mean, once x is by itself, you're done and you get to stop. Does that make sense? Because that's the goal, get the x by itself.
And it's just gonna be, whenever we're looking for that, it's just gonna say equations, like, okay,
It'll say, so it'll probably say solve or solve the equation.
okay.
Okay, let's go to this one. Remember, here's our boundary, left side, right side. What's by the x this time?
9.
9. We want to get rid of the 9. How do we get rid of the 9?
-9.
We're subtracting again, right? So subtract 9. And the reason we do that is because we subtract from both sides. But why do we subtract the 9? Cancels out, right? That's why we do it, to get rid of the 9. Now, what is 7 minus 9?
-2.
-2. And then we have x. And the x is by itself on the right-hand side of the equal sign, so we know we're done. Okay. Next one, our boundary, again right here by the equal sign. So what's by the x that we need to get rid of?
8.
The 8. How do we get rid of that 8?
Subtract 8.
Subtract 8. Everybody okay with that? Okay, so we subtract 8 on the left, or on the right, and also on the left. Both sides, again, do the same thing on both sides. 8 minus 8, again, cancels out. And on the left-hand side here, 5 minus 8 is what?
-3.
Correct, -3, and the x is all by itself over there. So that is our answer. X equals
I like
-3.
these.
You like these? Everybody likes these because they're super easy and fast, right? Okay, so any questions on this one, these three? Okay. Now, we've done some addition ones that we've had to subtract every time so far. I think we're going to have to do something else. We can't always do just subtraction. All right, so moving on to the next one. Again, our equal sign is our boundary. What's by the x that we need to get rid of?
-5.
The -5, right? So now this time, how do we get rid of -5?
Add.
We add 5. Does that make sense? Because it's like a -5, right? So we're going to add 5. Let me switch colors. Try to put my work in red here so you can see the difference. So +5. And again, if we add 5 on the left, have to add 5 on the right. Keep it balanced, right? Teeter-totter, keep it balanced. So the -5 and the +5 cancel out. And we get x equals
9.
9.
4 plus 5. And again, anytime you want to, if you want to check your answer, you just plug it back in to see if it's true. And this is really easy. 9 minus 5 equals 4. Yeah, 9 minus 5 equals 4. Okay. Are we good? Let's keep going. All right. So again, and you guys don't have to draw these lines. I'm just doing them as a visual to kind of keep the sides separated. If you want to do it, that's fine. So what's by the x that we need to get rid of this time?
-6.
The -6. How do we get rid of or cancel out that -6?
+6.
We're going to add 6, correct. And we add 6 to both sides. So this one cancels out. And we get x equals
4.
4. And then again, once the x is by itself, we're done and we get to stop. Okay. How about the next one? I'm not going to draw the line this time. If you want to, that's fine. What's by the x that we need to get rid of?
-7.
The -7, right? And how do we get rid of it?
+7.
+7. Okay. And when we do that, the x is by itself over here on the right, and -10 plus 7 is going to be
-3.
-3. That is correct. Okay, still okay? How about this one over here? What's by the x that we need to get rid of? The -8. How do we get rid of it?
Add 8.
Add 8. I should have really mixed these up earlier because you guys are just doing too well. So anyway, but that's fine.
You're just teaching really well.
Yeah, I'm not really teaching anything.
You're so patient.
You guys just know this already. So.
Yeah.
All right, so 5 plus 8?
8.
What?
No,
13 is a better answer there.
Yeah.
Okay. So you can't blame me for teaching you that. I didn't teach you that. 5 plus 8 is 8. That's a new math thing right there.
Mhm.
Okay? I can do that because she had to help me out and drag me along with all power school things. And anyway, so I was calling her all the time or emailing her all the time. Can you tell me what is going on here? Okay. So are we okay with example 47 here? Those three make sense? All right. Now, this one looks a little bit different because we don't see any symbol in between the 4. I'm gonna draw the equals the boundary here. The 4 is what we need to get rid of, right? But what is the math that they're doing between the 4 and the x? Remember when they're right next to each other? What does that mean? They're multiplying. Okay, so I'm going to put a little time sign here. How do you think we would cancel out multiplication? Divide. Okay, so what do you think we're going to divide by?
4.
Divide by the 4. We divide by 4 on both sides again so that everything stays balanced. Whatever you do to one side, you have to do to the other side. So the 4s cancel out. Now this is different. What happens when you take 4 divided by 4?
1.
You don't get 0 this time because before it was like x plus 0, right? Which is x. Here it's 1 times the x, which is x, right? So it's not going to cancel to 0 when you're multiplying and dividing. It has to cancel to a 1 because x times 1 is good. That's x. So we get x and equals 5. Okay, again, if you wanted to plug that back in and check, is it true that 4 times 5 equals 20?
Mm-hmm.
Yes. And again, that's probably one you could just look at and say, oh, I know the answer. But we're trying to get these steps down. Are we good to go?
Mm-hmm.
All right. This one's a little bit different, but we got to be careful here. So what's by the x that we need to get rid of? A -5. But again, what's the math that's going on? Are they subtracting?
No, divide.
No.
It's -5 times x, right?
Yeah,
Because they're
yeah.
right next to each other. So how do we get rid of that -5?
Divide by 5.
Divide, right? If you see that they are multiplying, you're going to have to divide. So divide by -5, divide by -5. This cancels out to be a 1. And x is now all by itself. And what do we get on the right-hand side?
-6.
-6, right? Because a positive divided by negative gives us -6. And that's our answer. Okay, does that make sense? All right. Let's do a few more of those types. Okay, this one, what's by the x that we need to get rid of?
Multiplication.
Yeah, it's
Oh, 8.
an 8 times, right? It's multiplication. And how do we get rid of it?
Divide.
We divide by what?
8.
8, because we're trying to get rid of that 8. When we divide, we get a 1. So x equals -3. That is correct. This thing, I think, moved out further from the wall. Okay. Next one. What's by the x that we need to get rid of this time?
-4.
The -4, and it is -4 times x, right? Does that make sense? How do we get rid of it?
Divide
Divide
by -4.
by -4. So that cancels out to be 1x, which is what we want. 1x is just x. And then -20 divided by -4 is
5.
5. And that's our answer. And then the last one over here, they switch the sides. What are we trying to get rid of?
7.
The 7. And do you see that it's 7 times the x? How do we get rid of that 7?
Divide by 7.
Divide by 7. Now, I'm going to tell you this because so far it's been pretty easy because once we started doing addition, it was all addition. Once we started doing subtraction, it was all subtraction. So probably right now, what you need to really focus on is recognizing what's going on. Are they adding? Are they subtracting? Are they multiplying? Or are they dividing? So when we divide by 7, this cancels out and we get x, and this will be 6. That's our answer. So they kind of have it all isolated into groups right now, but on your homework, it's not going to be that way. It'll be all over the place.
Yeah, homework is harder.
I know. It's rough, isn't it?
So
right.
harder things.
Are we good? All right. Now we've got our last group. Now division, remember, can be written in a couple different ways. You might see a division sign, you know, the line with the 2 dots, or you might see it written like a fraction. Remember that fraction just means divided by? So this means x divided by 5 equals -3. Okay, so again, I'm going to go ahead and do this time. What's by the x that we're trying to get rid of?
5.
That 5. And they are dividing by the 5, right? So as we learn, addition and subtraction cancel out. Multiplication and division cancel out. So what are we going to have to do to cancel the 5?
Multiply.
Multiply by 5 on both sides. Right? So multiply by 5 here and multiply by 5 here. This side cancels out to be 1x. And on this side, -3 times the 5, because this is times, right? We multiplied on both sides, so -3 times 5, -15. It's not -3 plus 5, it's -3 times 5, because that's what we were doing. We were multiplying on both sides, right? So make sure you do the same thing on both sides of your equation. Okay. All right, let's try these 3. I told you this first lesson was pretty easy, right? Did you believe me or not? Okay, what do we have to cancel out this time?
-7.
The -7. How do we cancel out the -7? Yeah, they're dividing. We're going to multiply. And we multiply on both sides. This is multiplying by -7, multiplying by -7. On this side, just cancels out. And we are left with x equals, and what do we get on the other side?
14.
And is it positive or negative?
Positive.
Positive, that's correct. Just wanted to double check. You said 14, you were right. I just want to double check, make sure we're all thinking. Negative times negative is positive. Okay, so there's our answer for that one. How about, okay, so like I said, you might see it as a fraction, divided by fraction like this, or you might see it divided by like this. It means the same thing. So what are we going to cancel out this time?
Where am I?
This middle one?
Oh, 8.
The 8. And how are we going to cancel it out?
Multiplying.
Multiply by 8. Multiply by 8 on both sides. So once on the left, again, here's our boundary, right? Once on the left, cancel that out. We get x equals, what is the 5 times 8?
40.
40. Okay, and that is our answer. And I think, is this the last one? Okay. So what are we going to get rid of or cancel out this time? The -4. And how are we going to do it? Multiply by, and I'm going to put in parentheses just so we are sure we're not subtracting. Multiply by -4. We're going to multiply this side by -4. This side cancels. We get x equals -36. That is correct. Okay. So the first section, pretty good. Okay. That's good, because if we can understand this, the rest of it is just going to slowly build on this stuff. Okay? And please, again, like I said, if you've got a question, stop me and ask the question, because that's why we're here, to try and learn, right? At least I hope. Or is it just to survive and make it through so you can get to the next class? I'm not sure. But if your next class is college algebra, then you're going to want to make sure you understand this.
It is. That's why I'm here.
All right. So on your My Open Math for section 1-1, there are 10 graded problems on that. So again, they're like this. They're not going to take very long, right? One step each. Again, if you, like you said, if you want to show your work and do it on a piece of paper and then send me that, I would say you don't have to worry about doing that unless you get something wrong and you want to show me or whatever. But these are just one step, so this one is not
But
going to
is
be.
it more
We
work
have
for
to-
you?
Yeah, it's
We have
whatever.
to type and email it to you. Oh,
Well, you could type it, or you could just take a picture of it and email the picture to me. Or if you don't mind, if I don't, because I usually try and grade it on Tuesdays before I come to class, because it's due on Monday night and I try and get it graded on Tuesday. If you don't care, if I grade it like after class on Tuesday, like Tuesday or Wednesday, you could just bring me the
Hand it
paper
to
and
me.
give it to me. That would be
That's
a way to do
better.
it too. So either way.